This video is going to cover the topic of writing equations with percentages. Be sure the date and topic are at the top of your page. The essential question that also needs to be on your page is, how do we write and solve equations that use percentages? We have already looked at examples where we have written expressions that represent situations that involve percentages. For example, if we know that a pair of AirPods is on sale for 10% off, we know that we could say, well, A is the price of the AirPods minus 10% of A, right? We can write that as an expression. Or we can combine those terms. Let me just write or here. And we could say, well, this was 1A minus our 10%. That means we're paying 90% of the price of the AirPods, right? That's nothing new. We've worked with that a little bit in class. That's just writing an expression that represents the situation. And as we've seen before, we can then substitute in and figure out the actual price of that AirPod. So if we know that the AirPods are normally $150, we can take our expression and substitute in $150. And of course, this means that we'd be multiplying here. And I'll just punch that into my calculator, and I would know that the price was now $135, right? The expression can help us solve that. Likewise, we can also use equations with percentages. So in this example, a blazer hat is on sale for 20% off. We know that Julian bought the hat, and in the end, he paid 20 bucks, right? So let's start with an expression that shows what we know. We know there was a price of a hat. We know that Julian took off, so I subtracted 20% of the hat. And then, of course, I can combine those like terms, and I'll say, well, that's 1 whole H minus my 2/10. Julian's paying 80% of the price of the hat. So that part we know. We can kind of think of that as step 1. And then step 2, we can figure out using this what the original price of the hat was. I know that if this is how much Julian paid, this expression shows how much he paid, and we know that in actuality he paid $20, then I know this is equal to $20. And from there, I can just solve algebraically, right? I would divide both sides by that coefficient. That would go away. And if I plug that in, if I punch that in, I know that 20 divided by 8/10 would be $25. So Julian would have paid originally $25 for the hat, but he purchased it on sale. Notice the first step was still to write that expression, and then I was able to see what it was equal to and solve. Here's another example. Remember commission, right? We used that term before. It's kind of like taking part of the money or part of the earnings for yourself, right? It's what you earn based on the whole price. So an art dealer makes a 40% commission on every painting she sells. So we know that algebraically, there's some painting that she sells, and 40% of it goes to the art dealer, right? And that's it. That's the whole expression, right? I can say 40% of the price of the painting goes to the art dealer. And in this case, we know that she made a commission of $200. That's kind of like the first step, right? Making sure we have that expression. But now, knowing that, we can figure out for how much the painting sold. So I know that this is the expression. I know this is how much the art dealer made. And I know that in actuality, she made $200. So I'm going to go ahead and set up that equation. And again, I'm just going to solve, dividing by that coefficient on both sides. And I would find that P, if I calculate 200 divided by 4/10, is $500. She must have sold the painting for $500. Again, working backwards, I can find that using my expression that I turn into an equation. Here's one last example. So up in Seattle, there's a sales tax. So Mara bought a pair of boots in Seattle, and she was charged 8% tax on the boot. So in this case, I know that she paid for the boots, and she paid for 8%, not 80%, but 8% more of the boots, to have a total of, let's see, we can make that a whole thing, 100% of the boots and 8% more. So she spent 108% of the price on the boots, right, including that extra sales tax. So that's my expression that shows how much she spent. And once we have that first step, we can go ahead and use the expression into an equation to find out how much the boots were originally, right, before the tax. So I know that this is how much she spent on the boots, right? The expression that represents the price she spent on the boots. But I know she spent a total of $54. So that expression equals $54. And from there, I'm just going to solve algebraically. So I'm just going to go ahead and divide from both sides. That leaves me with B. And I know that 54, if I punch that into a calculator or divide on the side, 54 divided by 1 8/100 is 50. So she must have spent, the boots were originally priced at $50. So she spent $50 on the boots, and the extra $4 was the tax. So again, this was just a quick connection of how we combine our knowledge of writing expressions with percentages and our ability to solve algebraic equations. It makes it a little easier to find like original values or original prices when percents have been added on or taken off a particular value. So be sure to have your notes ready for class, and we'll of course talk about this more together.